So topic 9 was pretty short. We only went over 4 sections. Please don't be watching this video until you have attempted this practice test and have done your best, because you need to be taking your test on Tuesday. My printer ink is kind of fading on me, but I think it's legible. All right, so for 1, 2, and 3, you're using this graph right here. And for number 1, you're looking at the relationship between EF and DG, and to see which ones of A, B, C, D, and E are, I guess, true. All right, first one says they're perpendicular. Well, obviously not. They're not even touching. Definitely not bisecting each other. They're not even touching. Definitely not collinear. They're not on the same line. So parallel and congruent are your options. So let's see. If they're parallel, they would have equal slopes. Up 1 over 4, up 1 over 4. So they are parallel. Now, they would be congruent if this was a parallelogram, and it would be a parallelogram if the right and the left are also parallel, and they are. They also have the same slope. The opposite sides of a parallelogram are congruent. All right, so now we have that quadrilateral, and we have to decide what it is. Well, it's definitely a parallelogram. Okay, I can tell by looking at it that it is not a square or a rectangle because it does not have 90-degree angles. I also know it's not a trapezoid because it has 2 pair of parallel sides, not 1. So, sorry, these don't work. So the only one I'm not sure of is a rhombus. Remember, a rhombus has 4 equal sides. I already know that because it's a parallelogram, opposite sides are equal. So if I knew side-by-side sides or consecutive sides were equal, then it would be a rhombus. So let's see how long EF is and how long ED is. Okay, well, I really would need those 3 points to be able to do that. So E is 2, 6. F is 6, 7, and D is 1, 2. So I'm ready to do the distance formula. So from E to F, I'm going to do 6 minus 7, or actually I'm going to do 7 minus 6. That's 1 squared, plus 6 minus 2 is 4 squared. 16 and 1 is 17. So I know that the top and the bottom are both radical 17. Now, ED would be this one and this one. 6 minus 2 is 4 squared. 2 minus 1 is 1 squared. And look at that. It's the same. Making the left and the right radical 17. All 4 sides are equal. It is a rhombus, A and B. Now, if Caroline is running all the way around this, in one loop, we want to figure out how far she runs. Well, each side was radical 17. So the exact answer is 4 radical 17ths. Now, of course, we can approximate that into the calculator. 4 radical 17. Ooh, she's got about a 16.5-mile loop. Alrighty. Number 4, we have a triangle of -2, 4, 3, 1, and -2, -3. And I need to determine if it's scalene, isosceles, or equilateral. Man, my guess is it's probably going to be isosceles, but I don't know. So I need to do the distance formula 3 times to find the length of all 3 sides. So let's do AB first. Let's see, 4 minus 1 is 3 squared. -2 minus 3 would be -5 squared. 25 and 9 is radical 34. Okay, how about BC? 1 minus -3 is 4 squared. 3 minus -2 is 5 squared. Ooh, 25 and 16. So far, it's definitely not equilateral. Could be isosceles. Let's try. I haven't got this one yet, AC. I really don't need to do the distance formula. It's a nice straight up and down. I can just count and see that it's 7. The sides, none of them are equal. This was a scalene triangle. All right, number 5. We don't have a little drawing, but probably want one. You've got L, M, N, P. And we're trying to figure out which of these statements would show that it is a parallelogram. Well, if we could show that the midpoint of this one and the midpoint of this one were the same, well, that would mean it's a parallelogram because the diagonals bisected each other. If I know that L, N, and MP are equal, that's really not enough. It could be a rectangle, but you know what? It could also be a trapezoid because a trapezoid has diagonals that are equal. That one won't work. What about knowing these two equal each other and these two equal each other? That will work because both pairs of opposite sides are congruent. Now this is multiplication here. If this slope multiplied by this slope equal -1, think about what that means. That would mean that they were opposite reciprocals. That would mean this in here made a 90-degree angle. But that's not enough to tell us that it's exactly in the middle or that they've bisected each other or anything. So while they are perpendicular and possibly could be a square or a rhombus, we don't know that. Won't work. And if M, N, and L, P equal each other, well, that's not enough because that's one pair of sides. So only A and C. All right, number 6. Which one of the following would show that the diagonals of a quadrilateral are perpendicular? So I have D, E, F, and G. So for the diagonals to be perpendicular, that would mean you have a right angle going on here. Well, is the slope of DF equals the slope of EG? Well, no, they would be parallel. They would definitely not be perpendicular. What about if this midpoint here is the same as this midpoint? Well, that tells us we have a parallelogram, but not necessarily that the diagonals are perpendicular. What about if we knew DF and EG equaled each other? Again, that could be a rectangle, but it could be a trapezoid. Not enough. What about if this slope multiplied by this slope equals -1? Well, that's it. That's how you know they're perpendicular. Remember, any number multiplied by its opposite reciprocal would give you -1, and that's what it's saying here. Okay, number 7, we're talking about a parabola. The first thing you need to know is the vertex. The vertex is going to come from these points here. It would be 3, 5. So the vertex would be up here somewhere. Now, the focus is up here, and the directrix would be down here. Remember, this distance and this distance are the P, and 1/12 is the same thing as 1/4P. So you can see that the P is 3. So 3 units up and 3 units down. So if this is on 5, the focus is 3 units up on 3, 8. The directrix is this y equals line, and it's 3 units down from the 5, so y equals 2. Okay, now for a circle, this is the center. That means that x minus 2 squared added to the y minus 4 squared equals the radius squared. Make sure you don't put 7 here. It's 7 squared, or 49. Okay, number 9. This is a circle, and it has a nice center on -3, -3. And its radius is 2. So you would have an equation of x minus negative 3 squared and y minus negative 3 squared equals the radius squared, or 4. This one here has a center of 2, 1. So we can right away eliminate these two, because those would have centers of negative 2, negative 1. All right. Oh, look, they both have a 9, which is the radius squared. The only difference is this sign here. And in a circle, the formula has a plus. It was A. Okay. Number 11, you have a parabola that has its focus up here on 0, 6, and it has a directrix right here. Okay, think about what we know. We know the vertex is right smack in the middle. Okay, so we can figure out the vertex if we need it. If this is 2 and this is 6, there's 4 here, so there will be a length of 2 and a length of 2. So our vertex is right below the focus. It's going to be on 0. 2 below the 6 would be 4. So there's our vertex. So in our equation, we would have to have a y minus 4. Remember, this part over here is the 1 over 4p. And the p is this distance of 2. 4 times 2 is 8. So 1/8. And then x minus 0 squared. And this is just an x squared, so C is the simplified answer. All right, we're almost done. 4 more. Number 12, another one with the focus and the vertex. The focus would be on 8, 4, somewhere up here. The vertex is 8, negative 2, right here. So we know that the directrix is going to be the same distance down here. Okay. This distance is your P. So from 4 to negative 2 gives you a P of 6. Ooh, all of these are 4 times 6 or 24, so all of those are correct. It looks like I really just need to know the vertex. Well, it would be a y minus negative 2. So the only one that makes sense is the y plus 2. And then this part's x minus 8. All right, now for an ellipse. This one has nothing going on up here, so your center is the origin, 0, 0. This came from 6 squared, and then 81 was 9 squared. Okay, so you know this is going to be an ellipse that's longer up and down. So the vertices are going to be those up and down points. So they're going to stay on the center part of 0, up 9 and down 9. The co-vertices will be the right and the left, which would come from the 6. So left 6 and right 6. So for 14, in order to be able to graph this one, you see that the center is still on 0, 0. This is like a 1 squared, or 1, and this is a 6 squared, or 36. So it's going to be longer going up and down. Okay, it's going to be 6 up and 6 down. 2, 4, 6, 2, 4, 6. It's going to be right and left, the square root of 1, which is 1. Make sure you notice that the 1 is right here. This is a weirdly numbered graph. All right, one more and you're done. The equation of ellipse centered at the origin, x squared plus y squared equals 1. Horizontal is 18, vertical is 24. So the long way is 24, meaning you have 12 up and 12 down. So on the y, 12 squared is 144. Right and left, it's 18, giving you 9 on each side. 9 squared is 81. And that's it. Make sure you study this, watch this video as many times as you need before you begin that test. And call me if you have questions. While this is easy, it can be tricky. See you soon.